Okay, so you have an app. That app does some stuff, which is pretty cool to me. You go, you log in using Firebase auth. Oh, go away. Yeah. Go away. Thank you. Nope. No, because I want to create them right now. It's actually going to be a quick create. But if you remember, we can log in using Firebase auth. So right out of the box, we have that. Then we've got a bunch of collections saved in Firestore. And then we've got a bunch of calls to Firestore. We can create a new user. We can update that user. And Albert, going to your point, we just used dictionaries here to update that user. Creating used set data. Updating used update data. For any collection, we do that. We can set data and update data. Then we also had GET requests, and that's where we started changing things for ourselves. We started saying, I could create a post, of course, I could get all posts, and I could also get posts for a user ID. I can filter down the information in my Firebase collections by fields. I can see where stuff equals a certain field, so if there are comments on a post, I can get all the comments for a post using that post ID. I can also get all posts created by a user by using the user ID and getting all posts that have that information with the creator ID that has that key. We set up kind of these relationships. That's going to be important for today's lesson. What I want to just work in here as well is something I'm sure will make everyone happy. We started to add something called a sorting criteria. This is an enum I started making that would let us figure out the order that our information should come back in. So when I hit the Firebase API, I go ahead and I say, hey, I want you to sort this from newest to oldest. So I used a very semantically understandable name for this sorting criteria. Sort out my information so that I see it from newest, so like the newest or the most recently created date. And the way I do that is I'm going to add some kind of information to my request that I make to Firebase, where I sort by date created, because that's actually the field, on the documents. Then I also added this variable, which is just for any case of a sorting criteria. That case will have a value called should sort descending, and that'll either return true or return false. So this is a good way of modularizing or abstracting out the behavior of sorting so that you're not using just the string, but instead you're creating something that your user or someone using your code could understand. We can make our own frameworks or our own wrappers that we publish for other people to use that are built on Firebase's stuff. I don't know what kind of licensing they'll make available to us, but we could build out a whole way to make it even easier for someone else to use Firebase. We could make that a CocoaPod. We could publish that. We could be CocoaPod publishers. It's like elite status. Cool? All right, so now we want to make this sorting criteria work. And where I was using it was in this getAllPosts function, because I wanted to get all posts in this list view controller. Sorry. No worries. I want to get all posts in here and sort them out so I saw the newest at the top. What wasn't working the other day was me trying to do something in a way that only works in JavaScript. We're working in Swift. Most of this code looks similar to JavaScript, but what I want to break down for you right here is think of line 103. I'll do it over here so we can kind of hear it. Think of line 103 as setting up the path to our data. So DB is like, where is the database located on the web? Then the collection is looking for something called posts because we set up some enum to do that. And then all I said was, look there and get the stuff. When I go to sort this stuff, I'm going to want to say collection.order. Come on, buddy. All right, I guess we got to build this so it can index collection.order. Come on, pal. Let's let it build for a second. But my goal here is I want to be able to say, look at this database. And if you remember from when we were talking about the web, I'd look at some URL, and I could add parameters to this. So typically the most important thing we saw was something like an app ID or like a, what do you call it? A user key. So these parameters would add to the request to a certain location some information. If I needed to have signed up for an app, I would have something like a user key or whatever you want to call it. It's adding more information to the request. The request is not just looking at a website. And what we want to do here is we want to basically add a parameter that says sort or order, and then tell it more information. So order by date. That's what I want to do here, whenever this lets me get access to my functions.
You could essentially sort by lots of stuff here, though.
Yep. We could sort by lots of stuff. We could chain a whole set of sorting criteria, too. Once we get this order function working, I'll show you what the difference between collection.order and collection.getDocuments is. But for right now, let's look at the type. Nope. Let's look at the type. If this ever indexes. Great. So we're going to wait for my computer. Let's see let's go look at DB. It's nice that all this exists, but firestore.collection is really what we're looking for in terms of Swift stuff. So DB is a Firestore location, .collection. We can go read the documentation. So I could go Swift, Firestore, collection. To go learn more, this variable is of a certain type. Get bigger. Let's go. Firestore, collection, documents, great. There's a document. Let's learn more about how to use the Swift SDK. Read data. Get data once. So db.collection, what is that? Come on, computer. This is really fun. If anyone has the project open, if you were to option click on collection, could you tell me what its type is?
Collection reference.
Thank you. So this is of type collection reference, which means that in the definition of collection reference is this getDocuments function, which lets me go into wherever that collection is, get back this thing called a snapshot. I don't know, what is that snapshot? It's probably of a certain type. What it is has something called documents on it, and in those documents, I want to look at each of them and create a post from each of them using a dictionary called data. And so this is where we have our model called post. And post has a specific initializer taking in a dictionary of string to any, getting all the values it needs in order to create a new instance of this, and then returning an instance only if it can use all those to instantiate a new instance of this post. If not, it returns nil. So the whole point of this compact map function is that it gets rid of any nils if that doesn't work out. So anytime that I go and I try to get the documents, which are just somewhere in a place called collection, where the specific name for that collection is posts, if I go to get those documents, the thing that gets returned to me is basically some set of documents with each thing having a dictionary called data, and then I just create a new post, so a new Swift instance of that post on my local client. So from a collection reference, I have this get documents thing. What we'll see in a second happens is if I want to sort or even to filter my collection, so I'm eventually going to do collection.order whenever I can get that function. It's going to create or work with an instance of a different type, FIR query. And that's just like making a specific query to a set of information. If we go and we look up the information for FIR query, NS object, and it has a function. I know this is Objective-C, but it has a function called getDocuments, just like our collection.getDocuments had. And so if we want to filter something, all we have to do is say collection plus sort filter settings dot get documents. And by that I mean if I let sorting criteria equals sorting criteria, this is fun, thanks computer, then the call I want to make is collection.order, then however this works out, order by sorting criteria dot raw value. I could also add a field here that I believe is called descending, and I will make that just sorting criteria dot, and then just this computed property off of that case. So should sort descending. Now I've abstracted all that information out. That's great. So the situation I have set up here is if I see any sorting criteria, so if this is not nil, then go ahead and get the documents in the same exact way. Yay, something works. Amazing. With the same exact format in the completion handling closure as I have in just a collection.getDocuments. So the collection is a collection reference. This function does the same exact thing. And my setup here is basically do that. If I see a sorting criteria, do that whole same exact thing. So instead of collection, instead of looking at the collections reference, and then getting the documents, I'm looking at that collections reference. I'm saying order this stuff. I'm saying sort it out by date, by this key, date created. And then, yay, finally loaded. There's going to be an argument here called descending. And it's just going to be whatever the Boolean value there is. Should sort descending, which for this case, the only case we have right now, is going to be true. This is all exciting because I can say, if you want to sort it, do that stuff that gets me posts. So it goes through and tries to create instances of posts from, that's right, from a dictionary, everyone's favorite tool. If not, just go ahead and get me all the posts. So whether I am just looking at the place where a collection exists, let me just close these up so we can see stuff. Whether I'm just looking at the collection itself, here I've got all my posts, or I am looking at the collection and saying, actually, need you to give me that information back in the same way. Both of those things use a getDocuments function. In the same way that our where field creates another FIR query, which has a getDocuments function. What are some questions about that? Can I start over? Yes. So here is what we were doing before. I was just looking at a collection. So I was looking at a place somewhere. I don't know where that place is. Firebase is handling where that place is for me. And I'm saying get documents, get the stuff there. And then this completion block here is basically what we've seen in any of our other managers where we go to get information, whether it's persisted or it's off the internet. I get back some stuff, I filter it out. The specific way I'm going to filter it out is I look at each thing in that stuff. There's a dictionary on it called data, and I have an initializer for my post object that takes information from a dictionary and then tries to create a new instance. Yay. If that fails, then I just return nil. So if I don't get all the fields I need out of that failing initializer, returns nil. If not, I get a post that I retrieve from the, ultimately what's a server? Firebase is a server. You're working with servers. So every time I go and get information from Firebase, it's returned in a dictionary. This guy? Phoenix, can you tell me back what this compact map does? It's very helpful here. That's right. It's doing a map over that set of data that we get called documents. And if this closure returns nil, so if this post initializer returns nil, it excludes that data from the resultant array. Post is an array of posts ultimately. This is just the same thing as a map, except it's a new kind of map that gets rid of the stuff that doesn't exist. So it cleans out all the stuff that we can't use locally. So that's what we did initially. We said, go look at a collection, get me the stuff in there. But I can do a whole bunch of stuff before I get the documents from that collection. I can order it, or like we did last week, I can say only get certain things, so only get the post where the creator ID is equal to whatever user ID was requested here. Where did we use this get posts, if anyone remembers? Yep, when we load posts for one user. So instead of like having to go look in persistence for a whole bunch of stuff or look online and then sort out information on the client, we can make a specific request to our server saying, hey, I'm in this specific view. I'm looking at this specific user's profile in our app, and I just want their posts. Here is the identifier for that user. So any posts where the creator ID is that specific identifier, get me those documents. This chain here is this object type called FIR query. All I want you to think of FIR query is the same thing as doing collection, except that it is doing whatever changes you make to it. So if you've filtered it, if you've sorted it, it's going to work ultimately the same, because both a query and a collection reference have this get documents function. Firebase built that all out for you. There's just a way of being a little more specific about the way in which you want to get your data. So the reason it didn't work before is because the way I thought it worked was you injected this order into the collection. But actually, this order makes this whole statement a different type than collection used to be. The nice thing here is that that changed thing, that thing that used to be a collection reference, it's now an FIR query, but it has the same function that gets stuff in the same way we're used to with a collection. So what I was trying to do before was I thought I could just add an order, almost like a setting for my collection, but instead you have to chain these things in order to be referencing the specific set of information you want.
You do it wrong.
Did I do it wrong? Yes.
Like you see them side by side.
Yes. All I did last time was I treated it like I was setting a value on collection. And so what it looked like was, hey, I think I add this setting to my collection. And then if I've added that, that's great. The collection should work the way I think, but that's not the way this framework actually works. I need to be calling get documents on this object that's been created here. So this function, it's kind of like, in terms of relationships, this function doesn't mutate collection. So this is kind of like sort versus sorted, where I thought order changed collection to give it some setting. But instead, what it really does is it just returns, this whole statement returns a different kind of object. That different kind of object has a get documents function on it too. But in order to make sure I'm doing that ordering, I have to call get documents on this object that's returned by this statement. So a way to make it a little more like parent is let query equal that, and then query dot get documents in the same way that we have collection dot get documents here. And so those are my two cases. So if I can get some criteria, I go and I do that thing. If not, I just get all of them in whatever order they exist in. But here's the super important thing, just real quick, is that it's the same completion. So the completion here is the same exact thing. Make sure those are all matched up. Okay. Yes. Sorry. Thank you. Can I explain what a snapshot is? Yeah. So it's a built-in Firebase type, actually. So if you look at get documents, it's going to return something called an FIR query snapshot block. Or if I look at just the regular get documents on a collection, well, that seems to not exist. So let's work with this one, because ultimately these things work in the same way. So get documents has a completion block. Let's look at the completion block. How can we do this? Well, let's just look inside of there when I make the request. So if I run this, let's look at snapshot, because I think, go away. I'm just going to look at snapshot because the documentation actually is not that verbose. So let's look through the object we get back instead. The way we're using it is there's some blob, some object that returns to us some documents, and those are effectively each thing in this collection right now in a dictionary form. So snapshot.documents, and then for each document in here, there is a data collection, which is just that stuff in dictionary form. It's really warm in here. Cool. So now let's look at my very, very slow Xcode. Let's print out snapshot. Snapshot is a query snapshot. It's got on it something called documents, where there's stuff in there. It's an array of stuff. This will definitely not work. Okay. We get back snapshot, then we can go looking through snapshot. It's got documents, just like we saw before. So it's an array of document snapshots. Those are pretty much the things in your collection. So I went to my collection. I said, get me back one big object that has all the stuff I want. In that big object are, in some form, that form being this query document snapshot, these things called documents, which we can look at, get that information as a dictionary from each document, and then use that however we need. Think of this documents as an array of things always, and then I can look at each document and get this data for each of them. It's just a dictionary. So think of this getting the data and then the failing initializer here as decoding information from your network helper. It's a two-step process because instead of getting back some encoded actual capital D data object, we are getting back something that we can use as a dictionary. And instead of using a codable object, all we're doing is creating an instance of some object we've defined using an initializer that takes in a dictionary. So this is in place of any network helper. We don't need to be making calls to this specific API using something that gets data and then JSON decodes it, like Albert was saying before, because instead, they've defined for us the format in which we're going to get stuff. We're going to get this big blob called a snapshot, which has in it documents. Each of those documents, well, say this was empty, I'd crash because there's nothing at that index, but it's just an array of this thing called query document snapshot. We don't really know how to use that. But the way we can use it, which they've built in for us, is to use it specifically as a dictionary where everything is a key, every key is a string, and then the type is any for any value. So I can use it in a very flexible way. Honestly, if you wanted to know more about Snapshot, there is plenty more to know. But in terms of using Firestore, I would say it's an instance that contains in it your collection. Think of it like a wrapper. And the reason you could think of it like a wrapper is there is an array of documents in there, which you'll convert into whatever type you normally would have decoded an array of stuff to be. But if you remember when we were creating our wrappers before, it was generally because we might have some blob that has in it let's say we are decoding from a dictionary, like dictionary website, might have in it a key, all the words, which is an array of some object we define called word. And then it might also have in it like, I don't know, request time, which is some date object. Might also have in it like client ID, which is some string. And so before, when we were decoding from JSON, we didn't need this stuff. So our models we created, we just said, look for the key word and make that an array of words in our word wrapper. Our snapshot is just like this, where it's got an array of documents, which is of type doc. And then if I look at each of those, defined on that document type is something called data, which gets me that dictionary that I'm looking to use to decode into an instance of post.
Why do you say it's an instance of a collection wrapper and
Because on Snapshot, there are a whole bunch of other fields. So there's this thing called cache metadata, where you could be sending information from your server. The cache money data, that's right. There could be a whole bunch of other fields on this specific snapshot object, because what snapshot is yes, the information we want to use, but also information about the request that we made, also information about, like, I don't know, how that request traveled through Firebase, whether it was authorized. So this snapshot here, yes, it has a field called documents. Maybe this is the best way to get in there. It also has something called account. Its properties exposed. Tells us how many things came back in that snapshot. It's not a count on documents. It's some other thing that we could use in order to like know how many things came back, instead of doing snapshot.documents.count -1 or something like that to add them all up. This is something that is just snapshot.count to tell me how many things I got back. You'll see this a lot with pretty much any request on Firebase, because they're trying to give you information about your request in addition to the information that you requested.
it's only talking about one specific question.
Yes. I'm not sure what the question is. Yeah. So in the past, and it's working exactly the same way as when we got JSON responses.
So what specific things are being sent back to it? And that's happening, including the besides what we requested.
All these things, this is in the documentation. There's a field called count, so I can do snapshot.count, which tells me how many things I got back. There's this thing called, and actually we'll talk about this on Friday, document changes. You can know when in time things changed, just in case you make a request for 10 documents, and then you want the next 10. Let's say I create 10 posts, and I make a GET request for them, but then in the time since I made that request, 2 more get created. If I want to add 10 more as I scroll, let's say this is in the table view, I'll look for any changes in that collection using information from some metadata, and this is really not important for right now, but there's a specific way you can say, I got my information at a certain point in time. From that certain point in time, give me 10 more after that. Not super important right now, but this provides you with a way of tracking that. It helps you make your requests in a very safe way, because say 1,000 people are using your app at once, they're all creating posts, but your timeline is just sorted out by date. You're going to want to get the next 10 by date from the last one that you pulled down. So the snapshot object itself has a whole bunch of information on it, but if we just want to be using Firestore to get and save documents, we just have to be looking at documents. So short answer, snapshot is a blob that has a whole bunch of information, including the stuff of the type that we want to be using. And we could use all that other stuff as well, but right now we're just using this to make a GET request. Mm-hmm.
In that situation, you would name that document wrapper, or whatever.
Sure.
So, in my mind, that would be an instance of one collection and not a collection wrapper.
So, I see. The connective tissue there is when you make a request, there's no such thing as a documents wrapper, but instead Firebase does you the favor of saying, hey, you wanted those documents of that type. Here's also some information built in for me. It's not defined on your server. It's not defined in Firebase, this response. This is automatically created. And inside of that response is some stuff that includes those specific objects you were looking for. And so when we used wrapper before, it was really to just deal with JSON that like we had a specific format for. But now that we're not dealing with JSON, we're just dealing with this big thing. I don't know what it really is. It's a thing called a snapshot that Firebase decodes for us and always creates in the same exact way. We haven't defined the way that it's created, but we do know that in there are documents coming from either the query that we created or just the collection that we're looking at. And then Firebase itself wraps up for us those documents with some other information. So we're not really worrying about creating a wrapper anymore as a type. We're not really like worrying about how this information travels. All we're worrying about is looking somewhere for where information is saved in Firebase. So I got some posts somewhere. And this is referencing that location. And then maybe I order it in some way, make it a query, who cares? This get documents works in the same way in that it goes and it looks for all this information here. And then it's going to return it to us, but it's also going to give us more information than just that, like these sets of documents. Donkey.
Is snapshot a terminology that you use for just that level of hierarchy, or is it like an arbitrary term for any kind of bunch of data that you get from a query?
Do you mean Firebase versus like other technologies, or within Firebase? Yeah, they just call a snapshot, and it's, sorry, I need a charger. They call it a snapshot for kind of what we were saying before. I'm getting the first 10 documents at a specific time. So it's a snapshot of how that collection looks when I've made that request. That collection might change, and so there's kind of a time aspect to it as well as a data aspect.
I was going to be talking about that collection of documents, and you wouldn't say a snapshot is talking about copies of the document.
Correct. So snapshot, bless you, is just the format in which a get documents request comes back. That's it. So let's load this stuff out. Before we take a break, just want to show you the really exciting part here. I hope you're excited. You guys remember closures? So let's look at this get documents function. Get documents has a completion block of FIR query snapshot block. The completion handler for both my queried documents and my regular documents is the same thing. So I'm keeping this here just so I can know. I can actually check this out. Var completion handler. It's going to be FIR query snapshot. It's just that closure. So I can define the completion handler beforehand because I'm using it in the same exact way twice. All I did was copy and paste this up there and save it as a constant using the completion handler both when I'm filtering and when I'm not filtering. So that helps you dry up your code. Most completion handlers look the same, right? Just look through the stuff, and give me the data I'm looking for. So all I did was dry that up. Don't repeat yourself, because closures can be saved as things, as types. And this is a closure that I've type annotated as the specific type that they want for their completion blocks. That's it. Closures rule. What? It is cool. How y'all feel about my closure? I think it's a nice, hard-working closure. It's done its best to adapt to any situation inside of this function. So you just move this note down here. So this is the last thing I'm going to say about Firebase, so you should ask questions now. That's it. Never, ever will talk about it. Just kidding. Jason? Yep. Yep. Let's take a look. So, excuse me. I've got a store image here. Store video is going to work in the same exact way, except, and I could refactor this to be store content or store media, where I convert whatever that thing is down to a data object. So I can convert movies into a data object. And then I just specify probably like with some enum, the content type as something different. Because this content type is the same thing as going into Postman and setting the content type there. So if you want to experiment with that, I need to create an account, apparently. Doesn't matter right now. But really all that's going on here is this is a post request. The store image is just a post request. Or they're calling it put data. That's because it could replace some data I have somewhere. This is just me saving something to the internet. And I'm specifying the type that that piece of media is going to be saved as. So this could have been content type application/JSON if I wanted to, for some reason, save an actual JSON blob into my storage. I could just change this content type with that encoded media file. Yeah. We looked through the free tier last week, and it's some, but not very much. I think it's like 5 gigs. Yep. So there's a native storage for images in which we can set the compression quality. That's saying how big we want that file to be. I'll leave you to experiment that with videos. It's probably a tiny bit more complicated, but it's still a media file that you're still converting into data. Ayla? Yes. Once you compress something, you lose all the quality that was lost in compression. So this image is only 80% as good as the original when it's decompressed. Yep.
To store an audio file, you use that to store media if you're going to change it to that as well, or that would need to go somewhere else?
You could store media in, yeah, you could store an audio file. Really, storage could be for really any file, but generally the practice is like we're going to put those things that aren't like databasey into storage.
So you mentioned
You could have, and then like you do this, you could have a folder that's all just like, nope. A folder that's all just like backup CSV files, which is really not as exciting as an image file, but definitely something worth storing, where you store the data from the previous day just to make sure that if you ever lose the data in your database, you have something to reference back to. Okay, next.
if you were paying for a streaming service, you wouldn't want to compress it.
You might still, just for cost purposes, like if you're saving 1,000 images a day, it's probably going to start to spike in cost because I think one of the plans is pay as you go, and it'll start to cost you a lot as you go.
Is that 0.8 when like actually most schools say you compare it to like 1?
Yeah, not that much, but like if you use Instagram, they don't encode at like 100%. They don't compress at 100%.
Or that depends on the quality of your building, or you can lower quality versus a high quality image,
Yay! All right, let's take a 9-minute break and then come back.